our last lecture, CEAS lecture event of the quarter. I'm Chelsea Foxwell, the Director of the Center for East Asian Studies, and it's my pleasure to welcome you here tonight. The CEAS lecture series was established in 2016 as an initiative that advances the Center's mission in fostering dialogue and interdisciplinary collaboration. In partnership with the University of Chicago Library, this annual public lecture series presents eminent scholars who concentrate on the study of East Asia from a variety of disciplines. The next lecture in the series will feature Christina E. from the University of British Columbia, and that will be held on January 30, also Thursday, 5 p.m. And she will be speaking on Imperial Testaments, Literature of Dislocation in Modern Japan. For more information on the entire series and to register, please see the poster located in the check-in table or check our website, ceas.uchicago.edu. And now it's my pleasure to introduce my colleague, Yuting Dong, who will be introducing tonight's speaker. So Yuting Dong is the Assistant Professor of East Asian History in the college in the Department of History. She received her PhD from Harvard in 2021 and is interested in questions of colonialism, history of labor and expertise, and environmental history. She's currently finishing a manuscript on Japan's infrastructure empire, which explores how Japanese colonial officials obtained knowledge and honed their technological skills from interacting with various local intermediaries and laborers. And she's also working on a second project that examines the commodification and politicization of air in Japan's colonial empire. So now, please help me welcome Professor Yuting Dong. Introduce yourself.
So I'll tiptoe a little bit. It is my great pleasure to introduce Yulia Frumer. Dr. Frumer is a Boon Jung and Song Young Kim Professorship of East Asian Science, Associate Professor and Chair of the Department of History of Science and Technology at Johns Hopkins University. She received her doctoral degree on History of Science from Princeton University and was a postdoctoral fellow at the Max Planck Institute for the History of Science afterwards. She specializes in the studies of history of science and technology in East Asia, as well as Japanese history and scientific translation. Dr. Frumer has published many articles, and they appear mainly in his Technology and Culture and Annals of Science. Her first book, Making Time, Astronomical Time Measurement in Tokugawa, Japan, came out in 2018 through the University of Chicago Press. In this book, Dr. Frumer explores the history of the measurement of time in Japan in conversation with Japanese history, history of technology, and history of science. Her work complicates our previous conceptualization of technological transformation and offers a fresh perspective for readers to reinvestigate the process of technological adaptation. Indeed, this book shows how Japanese scholars drew inspirations and methods from a wide variety of sources, both from Chinese and Western works, and incorporated parts of other knowledges on time into their design of timepieces and their measurement of time. Through her thorough research based on primary materials, some of them being cool images, I hope you can see it, such as this one. And there's also many cool images throughout the book. So Dr. Frumer also shows how the studies of measuring time influenced the geographical and spatial survey of Japan in the pre-modern era. Dagmar Schaffer, historian of science, commented that she literally felt the ambiguities of time come to life in Frumer's research account in relative and absolute terms. She's not the only one. I definitely learned so much more about time than I previously did from reading the book. So I encourage you who haven't read this book to read it. Today, Dr. Frumer is going to share with us her most recent research on robots and emotions. In this project funded by the National Science Foundation, Dr. Frumer examined how emotions shaped the decisions of robotics, policymakers, and consumers, and influenced the development of present-day robots in Japan. Let us welcome Dr. Frumer to share her insight on robots and our relations with robots today. Thank you.
Thank you so much for the kind introduction, and thank you everybody for coming here. It's late in the semester, late in the day. It's kind of cold, so I'm delighted to see so many faces, and I'm delighted to share my research with you. And I'm going to start with something that is fairly recent and not related to Japan. In 2019, IEEE, which is the largest worldwide organization of engineers, created a working group to establish a standard for ethical considerations and emulated empathy in autonomous and intelligent systems. And if you wonder what this technical term means, some of the examples are virtual assistants, wearables, music streaming services, chatbots, social robots, and what we called empathic technologies. This is huge, actually. Engineers don't usually like being regulated. There is a mantra that people repeat constantly that says, regulation stifles innovation. Historically, it's wrong, but set it aside, the fact that a bunch of engineers came together and they said, we have a problem. We need to talk about ethics. Something is wrong here, and things can go really, really wrong if we don't do something. So that's a huge, huge step. So in today's talk, I want to talk about why is it that they're so concerned, but also what is the role of history of technology in this conversation? How studying history, how investigating the history of how technologies are made can help us understand the ethical concerns in technological development. So social robots, that's the topic of my research. So obviously it's really, really relevant to what I'm doing. And I'm going to take you back to the early 80s. In the early 80s, Japan is known in the world, in Japan and outside of Japan, as the robot kingdom. What is really important to remember for us that these robots are industrial robots. And the reason that Japan became the robot kingdom in the first place is because in mid-60s, Japan experienced huge labor shortages in manufacturing sector. They didn't have enough workers. And Japan was so in love with economic growth that the idea that there won't be enough workers to produce, to manufacture things that could be sold, was very, very scary. And pushed a lot of industrialists, corporate owners, to invest in technology that was considered to be very, very risky, and that's industrial robots. American investors did not do that. They said, this is not going to pay off. It breaks down, it doesn't really work, it produces less products than humans can produce. And in America, we have enough labor force that we don't need this. But that was different in Japan. In Japan, people were willing to take risks and work out the kinks of the technology, even though that it didn't initially work. But by early 80s, they did. And then Japan owned 80% of world's robots and produced most of robots in the world. These were not humanoid robots. They look pretty much like this. They did have something that people call an arm, but not really like a human arm. And these robots were used in manufacturing. So how do we get from here to social robots, robots that are supposed to interact with us and take care of us? Here, again, we have a problem of labor. In the 80s, there was a shortage of labor of a different kind. And let me read something from one of the visionaries who envisioned the coming of social robots or personal robots. He talks about household labor. Dishwashing, not a fun thing. Everyone else in the family is having fun after dinner, but she has to do it. This is where women's burning need for my robot is hidden. And the term my robot, those of you who know Japanese history, in the 60s, the term my car was really, really popular, like with the advent of personal automobile. And then in early 80s, with the advent of personal computers, there was a term mycon before it solidified into pasokon, a personal computer. So he models this and they say, my robot, this is going to be the next thing. So my robot is going to help women to do the household work when women can spend that time on something meaningful for themselves, something meaningful that is not washing dishes. A couple of years later, this was written in 83 maybe. A couple of years later, he's much more explicit about what is the real motivation. With the passage of equal opportunity, employment opportunity law, women are working, and many of them are insisting that housework be shared equally between men and women. But this kind of shows you like who actually needs the robots, right? Like, is it really the women who need the robot, or is it the men that don't want to share this household work? There is a compounding economic effect here as well, because we're not just talking about washing dishes or doing laundry. There is a demographic problem. And the demographic problem was known since the 60s. The census in 1960 came out, and they showed that the Japanese population is gradually shrinking. But it became a real crisis in the late 80s when people realized that the situation is such that even if we force women to take care of all the elderly, which is impossible, economically it's going to backfire, because then women don't participate in workforce, they don't work in hospitals as nurses. We're going to have even more labor shortages in the nursing sector that already experience shortages. And if women don't work, they don't contribute to pension funds. And if they don't contribute to pension funds, the pension funds are going to dwindle, so that by the time that these grown-ups, middle-aged people, reach retirement, there is not going to be enough money in pension funds. So there is an economic bind here that, on the one hand, in late 70s, even early 80s, Japanese government was trying to convince women that it's in their nature to take care of the elderly. But this guilt shaming didn't work economically, because there was a need for women to actually work and both contribute to workforce and to economic fund. So this idea of a personal robot resonated, and a lot of government officials, but also corporate leaders, were buying into this dream that maybe in 20 years we're going to have personal robots. There was a problem, though, because the robots that existed at the time were industrial. This is not a robot that you can put in a household. First of all, these machines are really dangerous. These are huge, fast-moving, heavy machines that don't recognize if there is a head or an arm or something in the way. So safety regulations were such that humans were forbidden from entering factory floor where robots operated. If there was a need to do something with a robot, like maintenance or some kind of work, everything had to be shut down. Only then humans could go near robots. And once they're done, they're out, only then robots can start working again. So safety is really important. Next thing is factory floors are artificial environments that are built for the robot. They're basically huge holes. Robots are either stationary or moving on railing, and they just work there. Houses have stairs, doors, knobs, children, pets, furniture, fragile things, tatami floors, wooden floors. So all this, robots would need to operate in an environment that is not only contains all these things, but also constantly changing. And finally, robots that work in a factory, they just work with materials. If something goes wrong, maybe they spoil a batch of products. Whatever, it's just matter. Humans are different. If a robot makes a mistake, it can kill a human. And also humans are unpredictable. So when this idea of creating a personal robot came out, engineers started thinking, so what kind of things would we need in order to create a personal robot? Okay, safety, technical abilities to climb stairs, but what do humans need? And here there's an amazing kind of historical episode with male Japanese engineers in the 80s discovering emotional labor. And they suddenly say, you know, it's really interesting, but actually caretaking labor or service labor, it's not just washing dishes or doing laundry or cooking. Actually, you also need to support people and you know, can manage their emotions and be cheerful, and they may be cranky, and you know, sometimes actually elderly people could be abusive in a sense. So robot, in order to serve people, needs to be able to understand humans. And they actually use this term, understanding humans. How can a robot do that? You know, something like this. Like everybody's talking in Japan about how like Astro Boy Tetsuo Natomu was important in creating imagery. Not as much as Star Wars. Star Wars was the driver of what engineers were thinking. So, how can we make robots that understand humans? Japanese engineers loved science fiction, but they also knew how robots work. And they say, robots cannot do that. We can't engineer a robot to have a mind or kokoro. It's not there. But if a robot behaves like a human and seemingly guesses human feelings, then human psychology kicks in, and humans will start thinking that, yeah, this robot has a mind. So the problem now is not whether a robot can have mind or not, but whether we can convince humans that it has. So what we need to do is not only engineer the robot to have technical abilities, but we need to engineer the human mind. We need to do something with robots. We need to create systems, something in the appearance and the behavior of robots that will convince humans that this thing, this machine, this big appliance basically, has the capacity for understanding. How do you do that? And here I think it's really, really important for us to examine several of the techniques because I think that they're really, really telling. One of the things that I want to kind of focus on is something that came from the world of industrial design. Now, something that is really, really important to understand is industrial design as a discipline developed out of ergonomics. And as you know, ergonomics in its old form, but also even in the post-war, it's a science of labor, science of work. It's a discipline that explores how to make humans work more and better, how to make the environment such that allows humans to work more. Now, industrial design does a slightly different thing. And it asks, how can we make humans consume more? How can we make humans buy more stuff? What can we do in order to convince them to buy things that they ordinarily would not be convinced to buy? And one of the methods that they employ, it's called semantic differential method. It's developed by Charles Osgood, who worked in the military during the war and then went into industrial design in the post-war and employed the psychological methods in the industry. So it's a very, very interesting method, and I want to just walk you through the process. And I want to do so by using an example. This is a design of a side view mirror of a car that was created. It's a graphic design. It's not a picture. It's not a photo. So how do you design this? In Japan, automaking, it's a big thing in the 80s. When you design a car, you don't just think about things that we usually think of cars, like speed, gas, mileage, like that, how comfortable it is. These are important, of course. But in order to sell more cars, what is more important is to appeal to an identity. You need to identify how do potential consumers want to see themselves. So instead, you want to design a car that is fast and makes you feel carefree and makes your girlfriend faint with excitement. So this is the kind of image that designers, industrial designers, they set the goal themselves. So people who want to feel like this. We want to create a car that would appeal to them. How do you do it? How do you do it with a side mirror? You go to different shows, car shows, or places where a car, like the races, people see different cars. You eavesdrop on the conversations and you identify adjectives. What kind of adjectives people use? And then you create a set of opposites. So adjectives that you heard and something that is opposite of that adjective. And here I give like example of 5, but they would usually gather 20 or 30, this opposites. And they create a scale, either between like on 5 or 7 opposites. And they have a test group of potential consumers that they show them the picture and they ask them to rank and say how much it ranks between 1 and 5 on a scale, like between cold and warm, between timid and daring. And you may ask, how can a side view mirror be timid or daring? But it can. Because people, when they're asked this question, they actually answer and they give you a number. So you aggregate all the numbers, and this is kind of early algorithm, and you get an average, right? And you get this average, and you may then think, you know, I really wanted to design this car, but that's so much masculinity, and that's so much modernity and daring, that may actually repel some other consumers that are also important in the picture. So let's tweak it a little bit. Like by making the edge of the side view mirror a little bit rounder, and then asking the consumers, we can reduce the masculinity a little bit. You know, like we add a little bit more softness so that we expand the consumer base. So you can imagine it's a little bit of like a graphic equalizers for emotions. That you can just tweak tiny little bit things, that association between matter, how things look, how things feel, and people's associations, people's emotions. And one thing that is important to think here is that people have associations with shapes. And it seems quite benign in this case. You know, like we just appeal to consumers. But some things that people find appealing are also biased. And that is especially apparent in robotics. So roboticists were really excited about the semantic differential method, and they wanted to explore in order to design social robots, design robots that would appear caring and warm and something that potentially could take care of humans. So in very early 90s, they designed this series of robots, which technically are exactly the same. What they can do, how they can perform, even size-wise, they are the same, but they appear differently. You know, one, this P is something that is veiled in this like flowy and soft fabric, and then there is like this, you know, like a lamp-looking something, and then this figure with this clothes that definitely there is a reference to traditional Japanese clothes, but also if you think of late 80s and early 90s, this fashion of big shoulders that was like really, really important, that's something that people did. So they conducted this experiments with semantic differential, and some of the things that they discover probably will not surprise you, but some of the things surprised them. So kind of very like apparent, like, yeah, soft and light, like people associated with something that is gentle. Yeah, that makes sense. Smooth, rounded was associated with warmth. So this robot, K, was deemed the warmest of them all, even though that it's you know, just a lamp-looking kind of thing. Now, these material aspects were clearly associated with femininity and being caring and helpful. So here, soft light means gentle, means feminine. Same with smooth and rounded. There were a couple of interesting things that they discovered as well. One is that humanoid was not as important as some particular shapes. So this K scored much, much better than B on being warmth and caring. So the humanoid shape was, yes, like you want things to be kind of humanoid, but it doesn't need to be the more humanoid that you can make. Something that is metallic, but rounded, is better. Another thing that they discovered, and this may not surprise you, was that sexy was the opposite of warm and caring. So robots that scored higher on being sexy scored lower on being warm and caring. And when you think about this in terms of social norms of late 80s in Japan, it kind of makes sense, and not just Japan, in other places as well. Because again, it goes back to the question of labor and what kind of labor is assigned to different social groups. And if we think of women, it's horrible, but that's the fact in the 80s, that women are either assigned sexual labor when they're young and attractive, and this is what they're good for, or when they become middle-aged, then they're not supposed to have sexuality or anything. What they're good for is to take care of people. And humans can modulate themselves. Like we can be all of the above and change our appearance, change our clothes, change our behavior. Robots cannot. Like the way that they're made, both in terms of function and appearance, it's either or. And here it became very, very apparent that this biased sense of how women are viewed then becomes part of the matter, becomes embedded in the very physicality of robotic design. Now, I mentioned that this is early 90s. Early 90s was a period with a boom of artificial intelligence, development of artificial intelligence. It's kind of funny because what they called artificial intelligence, actually today we don't call artificial intelligence, but it doesn't matter. Like it is algorithmic calculation that is really, really important. And what they say here is that researchers in the 90s, engineers were saying emotions are going to be big in technologies that we develop. Like we had manufacturing of goods in the 60s and 70s, and then there was like information-based technologies, computers. Everything now is going to be about emotions. So, like computer graphics, animation, computer music, speech synthesis, creation of drawing documents, multimedia database, and of course, man-machine interfaces. Emotional information processing will be the key. But that's all great, and their development in software. Hard work, however, was rough. As much as people wanted to create these robots, social robots, that was not possible. And there were a lot of advances in terms of ability of robots to walk, to climb stairs, hold different objects. But with every technological advance, engineers just understood just how much they don't know and how much they're actually far from this ideal of creating a personal robot. So in the early 80s, they were promised by the beginning of the 21st century, everybody in Japan is going to have personal robot. By early 90s, they were like, no, that's not going to happen. So you cannot create a humanoid general purpose robots that are just going to come into your household and wash your dishes and mop your floors. But because emotions are important, there are other ways of working on robotics. And that is creating robotic pets. So this is a famous Sony robot Aibo that was developed in the 90s. Sony rightly identified an emotional need. 90s, as many of you know, were kind of gloomy period in Japanese history. Even if we don't subscribe to this idea that it was a lost decade, like economists call it, still, there were a lot of bad things happening. The mood was generally not that great, and especially after 95, after the Kobe earthquake and the Sarin incident. And there was just a lot of, juvenile delinquency, crime, things looked that they were going bad. And a lot of people were lonely. And one of the things that is interesting to see is that it's not just because of the bubble burst. People were exhausted. In the 80s, there was just work, get more and more and more, and it looked like it's going to produce something. And then in the 90s, there was an economic crash, bubble burst, all these bad things happening, and people were like, what am I doing this for? Why am I working so hard? Things are just not that great. And people need some kind of emotional support. And Sony was right in putting their finger on the sense and saying, we want to create a product that will satisfy emotional needs of our consumers, that would appeal to people who want engagement. It is a very, very important device for our purposes of discussing ethics, because one of the ways that they learn how to appeal to consumers is to simulate the sense of agency. Very interestingly, they created a software that would combine input from sensors information, so visual information, tactile information, audio information from the users with settings that they set on emotions, that they will have urges like being angry or sad or excited. So I'll give you an example. So the robot gathers information from its humans. They can hear voice. There's a speech synthesis and identifies emotion. So if owner is shouting or angry, it will identify this as angry emotion. If owner is speaking nicely and praising and saying "good boy," something like this, then it would be identified as a positive emotion. Or the owner could then reach a hand, and a visual sensor will identify that the hand is reaching. Now, if owner before that spoke angrily to the robot would be then set to an angry setting, and will start like barking its robotic bark and do a karate chop and reject this motion. But if the owner was nice and talked nicely and then similarly gesture, reach his hand, the robot will then shake paw gesture, right? So there's a sense that when users were using it, when users were looking at this, that robot responds to, and it did, like it gathers information from the user, that it has agency, that it just doesn't do what human wants to do, it actually responds. There is some kind of degree of recalcitrance. And this recalcitrance is based on an inner emotional state. So there is an appearance that there is something is happening within this robot's mind, that there is some kind of mind that is there, that makes it behave the way it does. And this appearance of agency was really, really important in creating a sense of engagement, because users felt that they can actually do something, that they have a relationship with this creature, this mechanical creature. And the more they interact with this, then there's also the robot grew because it learned tricks, kind of in the same way that Tamagotchi did. It's actually, they were inspired by Tamagotchi, that you need to grow this machine, you need to interact with this. And then the more they were engaged, they bought software to update and develop so that the machine can learn more tricks. They also had interchangeable parts. There's a really, really funny episode. At one of the models, you could actually physically come and take one of the legs and pull it out and put wheels instead, or put it a different model of a leg. And the Japanese engineers, they're talking to each other and they say, when we do it in Japan, people are really, really excited because these are new possibilities that you can update this dog. But then we tried going to the US and we did the same show. And once they pulled leg out, people started shouting, "Oh no!" And they're like, these Americans, they're so sensitive. They really think that this thing is alive. It's a machine. And there's we need to be mindful when we present these machines in America, because these people are touchy. So back to this dog. This really important, and it became a hit because it managed to engage users in a very, very interesting way, and people wanted to engage, and people felt that it satisfies the need for engagement, it satisfies the need for having somebody and not just being lonely and being entertained there. Immediately after that, there is this creature that probably a lot of you know. This is robotic seal Paro that was developed by Shibata Takanori. Shibata was, in the 90s, he was a postdoc at MIT in Rodney Brooks's lab, a lab that developed COG, this robot that was able to recognize emotion and also manifest emotions in face. And he actually set on developing a robot that would address human emotions. He wanted an emotional support robot. Initially, he wanted to build a dog, and unlike Aibo, to be it like a real dog. And then he realized that challenge was just impossible, both in terms of technical abilities and what dogs do. And then he said, well, I'll build a cat that is curled up and kind of sleeping. But even with a cat, it was very clear that people were so familiar with the cat that the moment that robot did something that not cat-like, that the magic was broken, and people understood that this is a machine. So he settled on a baby seal, and it's a Canadian baby seal. So maybe some people in Japan saw something like this on TV, but they didn't have a chance to interact with it. And it's also baby seal. They don't do much. They're just like adorable blobs that they kind of flop around, right? So there's not a lot of places where people could say like, oh, it doesn't actually behave like a real seal. Now, he conducted a lot of psychological experiments. One of the most interesting one is early. He created this kind of machine that looked like maybe an old-style vacuum cleaner, like a drum-like thing, that was just a drum, and attached to this was a rod that was moving. And he had a bunch of people going through the room and asking, what do you think this machine is? And what is it doing? And people had all kind of wild ideas of what it is. And then he had a group of users showing them pictures of dogs, just random pictures of dogs before entering the room. All of them, not only that they went and immediately started talking that this is a dog that is wagging his tail, but they would also start creating stories. They would say like, oh, this dog is happy, or like this dog is excited. And then he built in like some kind of tactile simulation that like if you strike, if you pet the drum, then the wagging, it would be like in the same kind of pace. And people started saying like, oh, it's feeling me. I have this attachment, I have this relationship. The dog is responding to my touch. And one of the conclusions there was that it really doesn't take that much to convince humans that something is alive and something like is an animal. It's just, one moving rod on a piece of round machinery. 1 degree of freedom in engineering terms. You don't need much sophistication, and you can do so much to convince humans. And I have another example here. I brought a little friend. I don't know if you can see. This is a present that I got from my friend from Norway. There are a lot of seals in Norway. It's not a robot. It's art. It's a toy. It's a carved wood, and I'm gonna send it around. But one of the things that you can see here is that, like, just by moving its little head around, like, you can create the sense that it's thinking, it's talking to you, and I'm happy to let you play this. It's adorable. It's just 2 pieces of wood. I like doing this. People also think, So there's what he realized, and it was really, really important breakthrough, is that you just need to give some cognitive cues to users to convince them that not only that the thing is alive, but it's also that it's responding to you, that it's talking to you, that it understands you, right? And baby seal maybe it doesn't understand you, but it has some kind of communication. And I also find it very interesting because the original idea was that you will have a personal robot that will take care of you, that will do your laundry, cook for you, clean for you, take care of you. But now we got a place that for elderly people to feel good, they need to take care of the robot, because not only that it's a baby seal, as you can see there, its charger is also shaped like a bottle feeder. So the elderly would hold it and strike it and feed it, and the sense of they taking care of a creature makes them feel needed, makes them feel that they have some kind of purpose in life. So there's a complete inversion, and both in terms of technology, we're not talking about really, really sophisticated machine general purpose of robots. We're talking about baby seal, which is technologically not that sophisticated, but psychologically really, really sophisticated. So that was a huge success, and actually, people find it as actually it works in nursing setting, that a lot of elderly patients, they find satisfaction in interacting with this robot, and not just in Japan, and all over the world. It was certified as the most therapeutically effective robot, at least until a couple of years ago, I think. In early odds, there was again attempts to make humanoid robots that they combined the technical abilities of bipedal walking, abilities to grasp, with this gathering of information from users in order to simulate empathy. what happens is that, Asimo is such a sophisticated robot. It can walk, it can do. There's the famous video clip where he plays soccer with President Obama. Everybody loves it. It's really sophisticated. Pepper is used as a conversation robot that, again, like sometimes in nursery homes, oftentimes in Japan you see it in train stations. But one of the ways that people, corporate entities discovered that building those robots is really, really expensive. And even if you build them, the maintenance and the constant work that they require make them impossible as a product. So research into Asimo was discontinued in 2016. And instead, Honda, that developed Asimo, they said, we will focus on remotely operated robots that could be operated by humans. That human from some other place can do the work while the robot will do actual movements. So there was separation. Instead of trying to create a robot that will do everything, there was a separation into thinking we will make useful machines like robotic beds, highly effective, really good. They sense the weight, the movement of the patient. They could be modified, really, really helpful in hospital setting. They can do one thing. They can be a bed that is helpful. Or we can have remotely operated robots that can do some work but require a human somewhere else to operate them. Or we will have machines that will satisfy emotional needs. And this one received a prize, I believe, in 2015, a machine that does nothing. This is actually not true. It does a lot because it has so many sensors. It gathers emotional information from the user. It senses your emotion, it senses your mood. And then it comes and it nudges you to interact with us and coos and being kind of like cuddly and soft and follows you around. I have now kittens, so it's like a kitten. It's a very. So it is the way that it's discussed is it does nothing. It does a lot emotionally. Now, what's the problem with this? What's the problem with these technologies, right? Why don't we want something like this? Look at this, it's really adorable. Well, let me show you an ad for another technology that I'm sure that many of you will find quite disturbing.
朝ですよ。起きてください。ねえ、起きてってば。おはよう。
おはよう。
今日雨が降るかもしれないから傘持って行って。急がないと遅刻しちゃうよ。
行ってきます。
行ってらっしゃい。気をつけてね。
19ページ、商品のラインナップについての。
おかえりなさい。
なんかさ、家で誰かが待ってるっていいもんだな。さっき思ったんだ。帰ってくるとき。おやすみ。
おやすみなさい。
I know, and I with my students, I spend hours on analyzing different parts of this video, and it is actual a product that people buy, and oftentimes it's shaped as a famous manga character. And what I want to emphasize here for the purpose of this talk is that, it's clearly designed to appeal to a certain population, a population of lonely, overworked males who spend hours on commute, work really, really long hours, and like his colleagues are flirting in the background, and he's just with this character. He comes back really, really late. Like, he stays in the office because he's the most junior. He stays in the office like the latest, and then comes home really, really late. Doesn't have time to socialize. Basically, eats dinner, drinks his cocoa or whatever, and goes to sleep to wake up in the morning and do it again and again and again. And it satisfies the needs. It satisfies the need for interaction, satisfies the need for some kind of company, satisfies the need, what I mentioned before, for feeling needed, that somebody is there, somebody's needs, but it doesn't actually solve the problem. And in the book that I discussed, I talk about how often robots in Japan, they were affective solution, and with an A, in a sense that they kind of mollified affect. They responded to an affect. They provided a solution to some kind of affect, but they were not effective with an E, because they didn't actually solve the problem. And one of the things here that I see that is disturbing is that it mollifies the urge to do something different. It keeps poor guy working, and without changing the situation that obviously makes him miserable. Now, it's not just in Japan. In a lot of other places, especially during the pandemic, this question of loneliness, need for company, became really, really urgent. And we have this amazing robot from Korea, Hyodol, that is also very, very sophisticated, that was developed as a kind of like a way to keep company with the elderly, and especially it allowed grown-up children to communicate through the robot, to check on their parents if they're still alive, to kind of ping through the software in the phone that robot reminds the parents to take meds. It has some kind of emergency contact information that can call nurses, and it's helpful a lot. But it's also very, very clear to design to appeal for people like me that have elderly parents, and there's all this guilt about not being able to actually be with them and help them, and especially during the pandemic, that people were physically prevented from doing this. This became a really like serious product in Korea. And here too, like recently, this is from New York Times last spring. People want virtual friends, AI friends, and this being US, medical services are lacking. We don't have enough therapists. So there are a lot of software that creates this basically like a virtual therapist that would work like and talk to you. And again, in the 1970s, Joseph Weizenbaum created this program called ELISA, which mimicked a therapist and responded with like answers, like you say it's like, hi, how are you doing? And maybe you'll type and like, oh, I'm worried. It's just like, and then the software will respond like, well, tell me more about this. And you will say something, and it was like, well, how does this relate to your mom? Like, it's a very, very cliche kind of like therapist answer. But then Weizenbaum himself was disturbed by seeing his secretary having long conversations with the software, even though it was like so rudimentary and it was like almost a joke. And yet he saw her and she's like, yeah, like I can talk to this. And we had at Johns Hopkins in 2020, we had a symposium on this virtual assistant. And they're actually like this, some people find it easier to talk to a machine, especially when we talk to Army veterans, that they feel that even medical confidentiality, like they cannot tell their therapist what they've been going through, what they've seen. So they would rather talk to a robot. But, so many but. So the standard finally came out this June, and oh my God, so many problems. So to just reiterate, and now it will make more sense, I didn't want to show it to you early. So these systems are all systems that acquire visual, sonic, biometric, textual, or personal data and use that acquired data to compute inferences and attempt to influence the affect of an individual or a population. And that may involve either simulated emotion by the system or the stimulation of the subject's emotion. And the problem is that it gives a reasonably informed subject the illusion or impression of understanding or relationship at an affective level that doesn't actually exist. It processes data semantically without respect to affect. So it just it calculates. There is no actual consideration to how people feel. And it gives the subject the sense that they're being heard in an affective sense. It's an illusion. They aren't actually heard. Potential risks and harms, bias. I mentioned several cases of bias that is so obvious. Engineers usually think of bias as kind of like, in terms of representation, when there is a group that is not very diverse, develops technology, then this technology potentially could be biased. Early voice recognition worked perfectly with California accent, especially if you're a male. People like me could not use Siri because of my accent. Siri just could not. It's slightly better now, but early times, Siri was not something that I could have a conversation with. Manipulation. These technologies, because it converses with you, it can convince you to do something that you don't want to. Like, for example, to buy things that you didn't mean to buy. The thing that gets most attraction is privacy and invasiveness, because in order to create this sense of agency, in order to stimulate empathy, there's a need to gather a lot of personal information, both bodily information and also information about person, but also all the systems have vision, so they can see inside homes. They know a lot about this. And these products that are created by corporate entities, so corporate entities now own this data that they can use for whatever motives that they want to, because they have this data. Overuse. Engender effective responses in the user such that it generates an otherwise unnatural attachment to the system. This can lead to misuse, overuse, or over-reliance on technology, or desensitize the user to real-life emotional experience. So, if you think of this ad that I show you, somebody who is interacting with this virtual girlfriend in a jar now has unrealistic expectations of what the relationship with a human can be. When talking about, especially, virtual therapist, or something that is related to a medical profession, there's a real problem of possible misinterpretation and misdiagnosis. Like a therapist can tell you to do something or diagnose you with something, which is not necessarily true. There can be some kind of algorithmic calculation that doesn't actually represent what the patient needs. And there's dependence that creates these are products that are designed to create a hooked consumer. In the same way that slot machines are designed to keep people going and gaming, a lot of these technologies are designed for you to continue buying upgrades, updates, similar technologies, buying new models. So the standard goes into, it's a quite a long document, a lot of recommendations, and between them, there are, engineers who design these things actually need to know something about psychology and cognition, and sometimes they do, but not always. Safety, how safe it is for humans to interact with this emulated empathy. What can happen? What can happen to humans? In case of Aibo, when Sony discontinued Aibo, people actually suffered emotional heartbreak because they got attached to this machine. And Sony doesn't care. Sony is just it's not profitable anymore. Bye. But for people, it's real harm. They experience loss. They experience real loss. Transparency, knowing how this machine's built, knowing how much information they gather, knowing what they're doing with this information, what kind of biases there are. Decision-making, how all these biases affect decision-making. Stakeholders need security, privacy, consent, watchdog supervision through development, deployment, and decommission. So they talk about the whole life cycle, not just developing a product, but actually looking how it is used, where it's used, and then decommission. When we talk about social robots, this is a large appliance. This picture of my lecture shows me with a retired pepper. You need to think of this as the way that people in Japan need to dispose of a refrigerator. It's a large appliance that needs to be disposed with pressure metals, with plastics that need to be somehow processed. Now, as historians, how can we contribute here? And I'm particularly thinking about this. it is really important to me that when we talk about how things are made, the historians of science and technology, we like the phrase of unblackboxing technology. So not treat it as a black box, not treat it as something that is a ready-made product, but actually thinking what went into building this technology, what kind of biases informed it, what kind of system informed it. Sometimes it's not necessarily biased because like all human knowledge is biased. It's just choices that were made and how these choices are still embedded in matter, how they still affect us. And something that is important, I talked about how the actual physical design can be biased. And we, or like people in Japan, may no longer subscribe to the norms of late 80s, so gender norms or other norms. But if it's still represented in the matter, in the robot, it means that the robot perpetuates this bias, even if otherwise society wants to move away from this. And expectations that women will be warm and provide health care, and this like strong association between femininity and care. And stakeholders' needs, like in the same way that I talked that the original idea of personal robot, that it would actually help women, but it doesn't actually help women. And as historians, we can say that the ultimate user that was envisioned is, well, the corporations that profit, but also, in this case, well, this is very, very privileged male engineers who thought themselves as the most important people in the world. And what I mentioned about Hyodol, like, that's in the same way that, like if you go to a pet store, a lot of products, they're not actually useful for pets, but they appeal to owners of pets. Here too, some of them, like with Hyodol, is the appeal is to the guilty children of elderly patients and not necessarily patients themselves. And in fact, there are some difficulties that it introduces labor demands for nursing homes. So all these things are something that we need to think through. There is a conversation to be had. There is something that we can say about the product. Engineers, those who made the standard, they did an excellent job, but they just looked at what they know, how things are made now. We historians, we can go back to the 80s, we can go back to the 90s, look at the decisions, look at the processes, looking at the methods, and then uncover things that maybe are not visible, no longer visible in the final design today. Thank you. That's it.